Okay, in today's video, what we're going to be looking at working with is solving with absolute values. Now, the big thing that we're going to be looking at, and the whole concept that's going to make this work, is an absolute value is going to take whatever is on the inside of the absolute value and make it positive. So in this case, if I have the absolute value is 8, of x is 8, then what I could have is, of course, x is being a positive 8. However, due to the absolute value property, where a negative value inserted into the absolute value will then become a positive, x could also be a negative 8, because if I take the absolute value of that, it does give me a positive 8. So what we're going to be looking at doing is really focusing on both the negative and the positive results of whatever answer we are dealing with. Our first problem on our review was the absolute value of 3x minus 1 is equal to 8. So just like on the what I was saying on the previous slide, if I have I'm going to start by using 3x minus 1 is equal to 8. This is a very easy equation to solve. It gives me, I then have 3x is equal to 9, or x is equal to 3. However, this is not the only solution, because like we said, if this is equal to a negative 8 on the inside, it would give us a positive 8 as a result. So we also need to solve 3x minus 1 is equal to negative 8. Again, we've got a very easy equation to solve. We'll have 3x is equal to negative 7, and x is also equal to a negative 7 divided by 3. We can always take our solutions and plug them back into our equation for x to verify that it is, in fact, a solution. Our next problem we have is 5x plus 13 is equal to 17. So same kind of deal, we'll have 5x plus 3 equal to 17. We'd solve this equation, so 5x is equal to 14, or x is equal to 14 over 5. Our second equation, we could have a negative 17 inside of our absolute value, so we'd have 5x plus 3 is equal to a negative 17, which would give us 5x is equal to negative 20, or x is equal to negative 4 in this case. Next equation, very, very similar to the previous ones. The only problem this time is this is not the only thing I have on my absolute value. I need this to be the only thing on this side of the equal sign. So I'm going to start by combining my like terms on this side of the equal sign. So 2x minus 4 minus 8 is equal to a negative 2. I would then continue to get the absolute value by itself by adding 8 to both sides. And that gives me the absolute value of 2x minus 4 is equal to 6. Now at this point, this looks just like the problems I was solving. So I've got my regular equation, 2x minus 4 is equal to 6, or 2x is equal to 10, or x is equal to 5. And then I also have 2x minus 4 is equal to a negative 6, because a negative 6 on the inside of my absolute value would give me a positive 6 as a result. This would give me 2x is equal to negative 2, or x is equal to negative 1. So in this case, I do have two distinct answers. Next problem, just the same as the last. I'm going to start by isolating my absolute value. So I've got absolute value of 3x minus 1 is equal to 4 in this case. So I've got 3x minus 1 is equal to positive 4, or 3x is equal to 5, which would tell me x is equal to 5 divided by 3. The other situation would be the inside of the absolute value being a negative 4. So I could have 3x minus 1 is equal to negative 4, or 3x is equal to negative 3, or x is equal to negative 1. So in this case, I also had two solutions. Okay, my next problem, I need to start by isolating my absolute value. So I've got the absolute value of 4x is equal to negative 8. Now this is a problem, because I know that my absolute value function here will not allow me to receive a negative value as a result. The absolute value function says that if it's a negative value on the inside, it must become a positive result. Because there is no way to get a negative result from an absolute value, we must say that this problem has no solution. Okay, this one's a little bit different than the previous, but it's still handled the exact same way. The only difference now is we have a second variable that's on the right side of the equation. We're going to handle it the exact same way we handled the previous. So I could have 3x minus 1 is equal to a positive x. I group my x's, so this would be negative 1 is equal to negative 2x, or x is equal to a positive 1/2, because in this case we'd have a negative divided by a negative does give us a positive result. The second case that I would need to look at is 3x minus 1, giving us a negative x. So I'm going to do the same result, and this time I have a positive 2x. Or wait. Okay, sorry about that. We'll have a negative 4x is equal to negative 1. Divide both sides by negative 4. We'd have x is equal to a positive 1 over 4. However, this problem is a little bit different. Because this is involving a variable, we can come up with situations that do not have a real solution. These could be what we call extraneous. So what we actually need to do is we actually need to verify that if I put this value in for x, it will be an actual solution. So I use 3 times 1/2 minus 1. And what I should have for an answer is I should have 1/2 when I'm finished. So half of 3 would be 3/2 minus 1 would be 3 over 2. I'm going to change that 1 to a 2 over 2 so I can subtract fractions, which gives me 1/2, which is precisely what I wanted it to equal. So what that's going to tell me is that this answer over here on the left is in fact valid. Now I need to check my second answer, the positive 1 over 4. So I'm going to set it up the same way where I have the absolute value of 3 times 1 over 4 minus 1, and I should have positive 1 over 4 as my result this time. So 3 times 1 over 4 would give us 3/4 minus 1. I'm going to go ahead and get a common denominator. So I've got the absolute value of 3 over 4 minus 4 over 4, or the absolute value of negative 1 over 4, which does give us a positive 1 over 4, which is exactly what we wanted. And so in this case, we do have two solutions, and both are valid. Okay, here on question G, we're going to be doing the same thing that we did on the previous example, where we start off with x minus 2 is equal to 3x plus 1, and solving for x. So I'm going to go ahead and group my variables. I've got 2x plus 1 is equal to negative 2. 2x is equal to negative 3, or x is equal to negative 3 over 2. I'm also going to need to do the opposite, where I have a negative value on the other side. Now, since I need to negate this entire side, I need to put a negative in the front. So I've got x minus 2 is equal, and then this negative would distribute throughout the parentheses, where I've got negative 3x minus 1. I'm going to group my variables. So this would give me negative 4x is equal to negative 1. And then when I divide, I'll have x is equal to positive 1/4. Now I need to actually go through and check my solutions. So if I use negative 3 over 2 minus 2 on the left side, so negative would be, when I get a common denominator, would be negative 4 over 2, would give me a negative 1 over, give me negative 7 over 2, or a positive 7 over 2 when I'm finished. If I try the other side, where I put negative, so I've got 3 times negative 3 over 2 plus 1. So I'm going to go ahead and put that over 1, so I can multiply this. This would give me negative 9 over 2. Then I'm going to get a common denominator plus 2 over 2. And in this case, I get a result of negative 7 over 2. So when I look at this, the left side gave me a positive 7 over 2. The right side of the equation gave me a negative 7 over 2. What that is actually going to tell me about this answer is this is extraneous. This is not a valid solution. Okay, let's go ahead and try positive 1 over 4. So I have 1 over 4 minus 2. When I go ahead and check this side, I've got 1 over 4 minus, when I get a common denominator, 8 over 4, which would be absolute value of negative 7 over 4, or a positive 7/4. So when I check this side, I get 7/4. When I check the right side of my equation, we have 3x plus 1. So 3 times 1 over 4 plus 1. So this would be 3 over 4. And when I get a common denominator, this would be 4 over 4. It does give me 7 over 4. So in this case, this does check out as a solution because I get 7 over 4 is equal to 7 over 4. It does tell me I did the question correctly, and I'm finished with that problem. Okay. I know this one was on our review. A lot of people were struggling with it. I'm going to do the same thing, combine it with some concepts we did earlier. So I'm going to start by adding 3 to both sides. I've got the absolute value of 4x plus 3 is equal to x plus 3. So this is going to tell me if I've got 4x plus 3, I would have a positive x plus 3 as a result, which would give me 3x is equal to 0, or x equals 0. The other possible result would be 4x plus 3 is equal to a negative x plus 3. When I distribute the negative, this time I have negative x minus 3. So when I group my values together, I've got 5x is equal to negative 6, or x is equal to negative 6/5. Now I need to actually go through and verify that these are actual solutions. So if I use 0 into my equation, I've got the absolute value of 4 times 0 plus 3 minus 3 equal to x, or is equal to 0. So if you noticed, I used the original equation that I started the problem off with. So when I work inside my absolute value, 4 times 0 is 0, so I've got 3 minus 3. And 3 minus 3 does give us 0, so this is going to check out as a solution. When I look at the second problem, so I've got the absolute value of 4 times negative 6 over 5 plus 3, and then minus 3. And what should I have as a result is negative 6 over 5, because I need x here as my solution. So 4 times negative 6/5 would give me negative 24 over 5. Get my common denominator, so plus 15 over 5 would give me negative 9 over 5. Now I'm running out of a little bit of room here, so I'm just going to kind of keep that for a second. So I've got the absolute value of negative 9 over 5 minus 3. So the absolute value of 9 over 5 gives me a positive 9 over 5 minus 3. I get my common denominator, which would again be 15 over 5, which gives me a negative 6 over 5. which is precisely what I wanted. So this answer does in fact check out, and I have two solutions again.